Right, so this is the 2014 Geometry External, question 2. We've got a cyclic quadrilateral here. We're told that CE is a straight line. Calculate the size of angle M in the diagram above. Well, obviously if this is a straight line, and angles on a straight line sum 180, so M must be 84. The reason is angles on a straight line sum 180. Right, calculate the size of angle J. So angle J is over at the side here. We'll keep going because this is a cyclic quadrilateral. Then N and the 96 must add to 180 as well, which makes N 84. That's because it's opposite angles in a cyclic quad, and then we can use angles in a triangle to work out J, and we get 55 degrees. So now we have to step that out. So we could start by saying N equals 84 degrees, and that's opposite angles in a cyclic quad sum 180, and therefore J equals 55 degrees, and that was angles in a triangle sum 180. And moving on to the next one, find the size of angle P. So we've got some parallel lines here. Good technique, make the parallel lines longer, and I can see the transversal cutting through there, and R therefore will be 32 alternate angles on parallel lines. And then we've got an isosceles triangle, so 180 minus 32, and then halve it to get P and Q, which is going to be 74. Each one will be 74 degrees, so now we've got to prove it. So we started by finding R equals 32 degrees, and that was alternate angles and parallel lines are equal. And once I did that, we were looking for P, so P is 74 degrees, and that was base angles in an isosceles triangle are equal. Right, part 2. Find an expression for angle P in terms of W only. So it's actually exactly the same as above. So we'll go through the same process. We started by finding R, which equals W, and that was alternate angles, parallel lines are equal. So we know this one is W. And then to find P and Q, actually, Q and P are the same. If you remember, we needed to 180 minus W gives us the remaining two angles, and then we'd have to halve, divide that by 2, and that was using base angles in an isosceles triangle are equal. Now that would probably be alright. If you want to practice a little bit of algebra on that, we could deconstruct the fraction, split it up, just check you agree that those two things are the same, and then simplifying that we get 90 minus W over 2. Right, and we're on to the next page. B is not the centre, so it might help just to try and make a centre somewhere. So we realise B is not. Explain why triangle ABC and EBD are similar. Right, well, we've got a couple of butterflies happening here. Angle at the circumference off the same arc, so I can see that angle C and angle D are going to be equal because of that. So if we use the 3-letter naming system, ACB is going to equal angle ADE, and the reason is angles at the circumference off the same arc are equal. And similarly, if you were to turn this upside down, you would find that that angle there, CAD, and that one there, CED, are also a butterfly. But they're just standing on the top arc. You'd have to turn that around. So we can say that angle CAB is the same as CED, CAB, or CAD actually is probably what we want to say over here. CAD and CED, and it's the same reason. And lastly, the coloured in angle. Those two angles there must be the same because they're vertically opposite. So CBA and DBE will be the same, and that's because they're vertically opposite. Angles are equal. Hence, triangle ABC is similar to triangle EBD because all their angles are the same. Right, now we're asked to prove, and these are sides, these represent sides, so that's side AB, which is that side there, times BD, which is this other side up here, and we're told that that's got to be the same as BC, that one there, times BE. So those are the sides we're dealing with. Now because the triangles are similar, we know something about the ratio of the sides, and there's lots of different ways to do this or to look at similar triangles. But I can see that the side AB divided by the side CB should be exactly the same as on the other triangle, the same sides and the same ratio. So this side here between the single angle and the coloured one corresponds to this side here between the single and the coloured, which is side BE. And we're comparing that with this side here, which is DB. Now before and what we should do next, solving equations, a little bit of cross multiplying. So I get AB times DB equals BE times CB. Now just to check we've got exactly what they wanted, BD and DB of course is the same side. I've got BE and CB is the same as BC, so we've proved it.